We're going to jump into linear equations in two variables and linear functions. If you'll remember, what is a linear equation? A linear equation was of this form. It had ax plus by equals c, right? And what made it linear? It was that x and y were both to the first power. And we talked about how to solve linear equations last week and the week before. Okay, if we put ax plus by equals c, that's called the standard form of the equation of a line. We're going to talk today several different forms of the equation of a line. There's no one that's better than the other. They all have advantages. If I were to ask you what's the equation of a line? Most of you are going to say y equals mx plus b. That's the slope-intercept form of a line. This is another form of a line, ax plus by equals c. It's called standard form. Okay, let's see. Let a, b, and c represent real numbers such that a and b are not both 0. A linear equation in the variables x and y is an equation that can be written in the form ax plus by equals c. That is called the standard form of an equation of a line. Note, a linear equation has variables x and y each of first degree. That's what makes it linear. Okay, let's go do an example. Go graph the lines. 4x plus 2y equals 8. Okay, if you're given a linear equation in standard form, it's real easy to graph it. You do so by finding the intercepts first, x and y. If I let x be 0, do you see that I would be covering this up? That would be gone if x were 0. So I would be solving 2y equals 8. Divide both sides by 2, and I get y equals 4. So I have the point 0, 4. That's my y-intercept. We good? 0, 4. Okay, if I let y equal 0, so now 2 times 0 is gone, correct? And I have 4x equals 8. To solve for x, I divide both sides by 4, and I have x equals 2. So I have the point 2, 0. So I'm going to go over onto my graph and plot the points 0, 4. That's my y-intercept. Plot the point 2, 0. That's my x-intercept. And then connect the dots. There's my line. 4x plus 2y equals 8. Questions? If a line is given to you in standard form and you have to go graph it, go find the intercepts. You can cover up the x's, solve for y, cover up the y's, and solve for x's. Okay, number 2, what if x equals 3? Let's go do some points. It says that x always has to be 3, correct? So 3 what? 0, sure, pick one. Okay, give me another point. 3, 1. You get to pick what the y's are because they can be anything, but the x's have to be 3. So let's go graph it. X has to be 3. We have the point 3, 0. We also have the point 3, 1. Connect the dots. There's your line. What do you notice about that line? It's starts with a V, vertical line. Good. Okay, what about the line y equals 2, or sorry, y equals negative 2? Again, y always has to be negative 2, so I'm going to pick 2 points where y is equal to negative 2. What are the x values? Does it matter? Just pick 2. What about 0 and 1 again? Okay, go graph it. I have the point 0, negative 2, and I have the point 1, negative 2. What do you notice about that line?
Horizontal.
It's horizontal. When you have y equals a number, you get a horizontal line. When you have x equals a number, you get a vertical line. Okay, so let's talk about what makes one line different from another. One of the characteristics we can talk about with a line is the slope, the steepness of the line. Before we go look at the line, though, and talk about that, let's find out how to find the slope between 2 points. So the slope of a line, the steepness of a line passing through x1, y1, and x2, y2. The slope formula is m equals, why do we use m, by the way? Do y'all know? You can Google it if you're really interested in it. I had at one time heard that it was from the word Mount Tyr, which means to climb. I have no idea. But anyway, we always use the little lowercase m for slope. So m is equal to the change in the y values divided by the change in the x values. Here's the formula, y2 minus y1 over x2 minus x1. That's what you need to know. Okay, provided that x2 minus x1 is not 0. You can't divide by 0. Does it matter if I do y2 first or y1 first on the top? Well, yes and no. I'm going to tell you this. This is also equal to y1 minus y2 over, if I do y1 on top first, I have to do x1 on bottom first. So it doesn't matter what point you start with, but if you start with y1 on top, you have to start with x1 on bottom. Does that make sense? And I usually put my finger on the point that I start with, and I'll show you what I'm talking about in just a second. Okay, some examples. Go find the slope of the line passing through the given points. -4, 1, and 2, -2. So I'm finding the slope. If I start with this y value, so I'm going to do 1 minus a -2, correct? Y minus y over, I have to start with this x value on the bottom, -4 minus this x value, which is 2. Again, I do y minus y over x minus x. That's all you're doing to find the slope. Okay, what do you get? 1 plus 2 is 3. -4 minus 2 is -6. So my slope is -1/2. Questions? Go try number 2. 3/4, 2, and -3, 17. Okay, the slope between these 2 points is going to be, I'm going to start with this y value this time. So I'm going to write 17 minus 2, because y minus y, over, if I started with this y value, I have to start with this x value. So -3 minus 3/4. (17 minus 2 is 15 over, I have no clue, -3 minus 3/4. -3 minus 3/4 as a fraction is -15/4. So now I need to do 15 over negative 15 fourths. 15 divided by negative 15 fourths is negative 4. We good? How about the points 4, 3, and 4, negative 1? The slope will be, I'm going to start with this y value, y minus y. So I get 3 minus negative 1 over I need to start with this x value. 4 minus 4. 3 plus 1 is 4 over 0. Can you do that? Can't divide by 0, so I'm going to say that that slope is undefined. Or you can say that there's no slope. Either way is acceptable. No slope or undefined slope. Number 4, what is the slope? I'm going to start with this y value. So negative 1 minus a negative 1 over 6 minus 2. So I get 0 over 4, which is, what's 0 divided by any number? 0. Let's go graph these two lines that go through these points. On number 3, if I were to graph that, I would have the points 4, 3 and 4, negative 1. Ooh. What kind of a line is that? It's a vertical line. What's the slope of a vertical line? Undefined. So I'm going to go down here to the little red statements and say the slope of a vertical line is undefined. On number 4, if I were to go graph those 2 points, the line that goes through these 2 points, I have the point 6, negative 1, which is here, and 2, negative 1, which is here. So what kind of a line is that? It's a horizontal line. What's the slope of a horizontal line? 0. The slope of a horizontal line is 0. The slope of a vertical line is undefined. Okay, how do you remember that? As silly as this is a mountain, and we're going to go snow skiing. And when you ski uphill, very difficult, by the way, you're usually huffing and puffing, and you're saying to yourself, puff, puff, this is hard work. So when your line is going uphill from left to right, you're puffing because the slope is a positive number. The slope is always bigger than 0. It's a positive number if you're going uphill from left to right. But once you reach the top, you tell yourself this is quite nice because the slope of a line that's going downhill from left to right is negative. Got it? Positive goes uphill from left to right, negative slope goes downhill. If you're on a flat mountain, how much fun do you have? You have zero fun because the slope of a horizontal line is 0. But they put a bunny trail up on the middle of the mountain, and on the side of it there was a cliff, and you fell off, and you screamed out, "Oh no!" Because what's the slope of a vertical line? You can either say that there is no slope, or you can say that it is undefined. So the only one I keep track in my mind is that the bunny trail that's flat is 0 fun. Slope of a horizontal line is 0.